This is not tonight. We're going to start this evening on Saturday night. Now, the difference between tonight and Saturday night isn't great. I mean, the moon's going to be in a slightly different spot. And that's why we're going to Saturday night, because the moon's going to do something interesting Saturday night, which it will not do this evening. But otherwise, what I'm going to show you is pretty much what you would see tonight, except for this one little thing the moon's going to do, which we're going to talk about in a minute. But before we get into the moon and we get into the stars, I want to talk a minute or a couple minutes about our star, the sun. You see, I have it up here just before sunset, maybe 15 or 20 minutes before sunset. And the sun is a star, just like the stars you see outside at night. And it's been doing some interesting things lately. So I want to begin by talking about our star. Now, this program is called Stellarium that I use to kind of wander around the sky, and it works great. And you can zoom in on the sun like we've done here and take a look, and you see some sunspots and some of the activity here. The sun, those sunspots are magnetic storms on the sun, where you know how the Earth has a magnetic field which makes your compass point north. And on the Earth, it always comes out of the magnetic North Pole and surrounds the Earth, comes back at the South Pole. On the sun, it breaks out all over the place. And where the magnetic field breaks out of the surface or the photosphere of the sun, it cools the gases down because the rising heat can't rise in those spots, and it makes them look darker. They usually occur in groups or pairs. And and sunspots go through an 11-year cycle. And right now we're near the peak of that cycle, which means for the next few months, we're going to have more sunspots than is average. So this program gives you kind of a generic look at what the sun might look like. I want to show you a picture of the sun I took this morning. So we're going to leave Stellarium just for a moment and come over here. And this is the picture I took, actually not this one, I took it yesterday morning, through the haze because we had lots of clouds. So it's not as sharp a picture as you might see another time. And you can see that we have a sunspot facing almost right in the center there on the meridian of the sun. And you've got one big one and a bunch of little ones. And the magnetic field probably comes out of that one big one and goes to all the little ones around it. You see a little one here. Now, what this does is it can have some pretty dramatic effects here on the Earth. This picture of the sun is through what we call a white light filter. Now, if any of you observed the eclipse back in April, how you probably wore eclipse glasses. Well, those are white light filters. Sometimes you look through them and the sun just looks white. Sometimes it might look a little yellow or orange here, depending on the filter. But essentially, all it's doing is taking all the light of the sun, which is way too bright for your eyes, and cutting out like 99.99% of the light. So it allows just enough light to come through the filter so you can safely look at the sun and not damage your eyes. And when you do that, you get rid of the glare. You don't hurt your eyes, which is a very important thing. And you can see sunspots like this. Now, astronomers use different kinds of filters, and some of them are much more expensive. One of the most common ones you'll find is called a hydrogen alpha filter. And that, in that case, the sun would look more like this. Now, that's a much more interesting view of the sun, I think we'd all agree. Well, the sun is made largely of a gas called hydrogen. And hydrogen, when it's hot and glowing like the sun, gives off a lot of light in a very specific wavelength, which is commonly called hydrogen alpha. So this filter filters everything out except for that light, and it takes that light down to a level where it won't hurt your eyes. And then the sunspots sort of disappear in this light. But you see all these interesting things happening, like these things that appear to be leaping off the sun. These are called prominences, and they leap from one sunspot to another. So you've got the magnetic field going between two sunspots, and that magnetic field is invisible. But hot glowing hydrogen plasma will flow through the magnetic field, and that's what this stuff is here. And it's called a prominence, and it can last as long as the sunspots last. Sunspots can last from a week to 2 weeks, generally. Some a little longer, some a little shorter. And prominences can last like that. Now, these magnetic fields are dynamic and they're moving and fluctuating as the gas flows through them. And sometimes it gets twisting on itself and it snaps. When it snaps, there's a burst of energy that comes out, making these bright spots like this one on the right here. That's called a solar flare. And that's a burst of energy that comes flying out at the speed of light. And that energy will reach the Earth in a little over 8 minutes. So it's a really powerful burst of energy. But what is really fascinating is sometimes these magnetic field lines get really out of control and they break and burst. And then it's not a burst of just energy, it's a burst of particles that go drifting off into space, not traveling at the speed of light. It's called a coronal mass ejection. And that's what this thing is here on the upper left-hand side. See that huge mass there? Almost as big as the sun itself. Not nearly as dense or anything. It's just hot glowing plasma and hydrogen floating off. And that, if it's coming towards the Earth, it's going to interact with our planet. It can take it 3 or 4 days to get from the sun to here. So it's not traveling at the speed of light like a solar flare. Well, we had a coronal mass ejection back on May 10th. And this is the sun on May 10th through a much better, this is a white light filter again. And you see all these sunspots here, just a huge group of sunspots, another set here and another pair over here. And there was a coronal mass ejection that came out of this massive sunspots, and it came heading towards the Earth. And on May 10th, it interacted with our atmosphere, with our planet. When it hits the Earth, the Earth's magnetic field kind of protects us like a natural force field. That energy flows around it and comes down close to the ground near the poles where the magnetic field comes down. And when it does that, it reaches the upper atmosphere and makes the air glow, and it creates the incredible northern lights. Maybe some of you saw those that night. If you, we had a beautiful clear evening that night all across the state of Maine. And we had northern lights that weren't just in the north, they went almost all the way to the southern horizon. It was a tremendously beautiful set of northern lights. I've seen dozens and dozens of displays of the aurora borealis, and this was probably the biggest one I've ever seen. This is a picture I took. I took this in not far from where I live in Hinckley, Maine. Now, if you were on social media, you may have noticed after this happened, there were tons of pictures like this, beautiful pictures of the Northern Lights. And a discussion quickly came up was, well, do they really look like that? Because cameras can pick up light that our eyes can't see, and they pick up faint color our eyes can't see. So, and they weren't quite this vivid. You saw all the structure, but it wasn't quite so vivid. So I took this very picture and I took the colors down to what I saw by just looking up in the sky. And to my eyes, it looked much more like this. Still, you see lots of that structure, and you can see some greens and some magenta and a little bit of orange and stuff here. But those intense colors like this, they are really there, but the part of our eyes that sees that color needs a lot of strong light to see it. Camera can see it where our eyes can't. So it's quite beautiful to see. It's even more beautiful in the camera. To our eyes, we saw this. Now, the one aspect you don't get by taking still pictures like this is the fact that these things are moving. They look like curtains blowing in the wind. They're jumping up and down quite rapidly, much faster than a cloud would drift across the sky. And so that aspect you do see in real time. And they can be incredibly beautiful and cover the entire sky like you can see here. Now, the different colors are caused by different molecules in the atmosphere and how high up they are. The reds are caused by oxygen at high altitudes. They're 150 miles above the surface of the Earth. The green, which is probably the most common color, is also oxygen, but at a lower altitude where there's a little more pressure on it. And then you get violets and blues, which are caused by nitrogen, and they're even lower in the atmosphere. But even the lowest is still 60 miles above your head. So if you look up and you see the northern lights and they look like they're just dancing over the treetops, they're at least 60 miles up. And they're huge and they're very far up in the sky. Now, most northern lights are more like this. You get this glowing pattern in this northern sky, but if you turn around and look in the opposite direction, no northern lights. Whereas the one we had in May covered the entire sky. I'd never seen it quite like that before. And when you're right underneath them and you look up those curtains, it kind of looks like you're laying on the floor under curtains and you see the curtains undulating. It looks like a starburst. It's quite intense and just amazing thing to see. I wish we had the motion in here. I wish I thought to take a few video clips so you could have seen that. So there's a scale. If you want to know when this is going to happen, there's a scale called the KP scale. And everyone wants to know what KP stands for. It's German for the planetary index. And the scale is 0 to 9. And for us to see it here in Maine, you've got to have a KP of about 6 as the lowest it can go. If it's lower than that, we're not going to see it in the state of Maine. So the higher the number, the stronger the aurora, and the further south you can see it. The aurora we had on May 10th was a KP 10, which means this is at the top of the scale. I saw one place where they listed it as KP 11, and the scale only goes to 10. I think they'd watched a few too many movies or something, but it was that intense. So we need a 6 or higher to see it in the state of Maine. So I just went online about 4 hours ago to one of the sites that will tell you aurora. And right now we're at a level 6. So we're at the point where perhaps if you had a clear night tonight, you might see not like we saw on the 10th of May, but you might see some faint aurora in the northern sky. We're right on the edge of it right now and will be for the next 2 or 3 days, including Friday and Saturday night. So this is the sun tonight or this morning. It's kind of what it looks like with that sunspot coming right in the center facing the Earth. That if there is any types of flares or coronal mass ejections, it's going to come right at us. So that's our sun. And it does some interesting things, and it's what creates the aurora borealis. So what I like to do now is put that sun down and look at the sky and see some of the interesting things we can see. So let's let the sun go down. Now, if you get outside on tomorrow night or Saturday night or even Sunday night, wait till the sun goes down, but have your binoculars handy because right after I don't want to go too fast here. Right after the sun goes down, look in that direction, but wait till the sun's gone because you do not want to look at the disk of the sun through even a pair of binoculars. You'll damage your eyes quickly. But if you watch in that direction, right where the sun went down after it's below the horizon, look for a star that might, and you won't see it with your eyes. It's right there. Let's go a little bit further and it might brighten up a little bit, but it's going to get lower. And that little star is actually the planet Venus. You're going to have a hard time seeing it because it's right in that glare of the sun. Even though the sun's below the horizon, it's going to just barely show up. And you might, if you're lucky, see it with a pair of binoculars. So scan and see if you can find it. Venus is going to be out for a while this summer, and the view is going to get better as time goes on. Right now, just trying to get that first early glimpse of Venus as it's coming out from the glare of the sun. It's just an interesting challenge to do. So if you're hunting for that and you can't find it and you get a little frustrated, let it go and look off to the southwest, and you're going to see another incredible sight. You're going to see a quarter moon that we'll have on Saturday. Now, remember, this is Saturday night. And the reason Saturday night is important is because of this moon. Take out your binoculars and look at that moon. And with the moon on Saturday night, it won't happen tonight or tomorrow night or Sunday night, just Saturday night, right beside it, you're going to see a bright star. That star's name is Spica. It's just to the left of the moon, and it's very, very close. This is right after sunset. By 10 o'clock, give or take 15 to 20 minutes, the moon is going to move towards, it's getting closer and closer to Spica because the moon moves eastward, and it's going to occult Spica. Now, the moon goes in front of faint stars all the time, and we don't pay much attention to that. Spica is one of the top 20 brightest stars in the sky. And when the moon, the dark part of the moon, the sun, the nighttime side of the moon is going to hit Spica first. And it's kind of fun to watch it when it goes behind because you see this bright star, you see this bright star, and you see this bright star, and then it just goes out. It just disappears when the moon goes in front of it. So that's going to happen sometime in it. The exact time I'm not sure, but sometime between 9:30 and probably 10:30 Saturday evening. And you won't see it come out the other side because by the time the moon covers this goes all the way across Spica, the moon will set in the west. So we'll get to see Spica disappear, but not reappear. When you do get a chance to see it reappear after an occultation, it does the same thing. It snaps into view. But my favorite part is when it goes behind the nighttime side because it just really stands out. Now, while we're here, let's take a look at this moon with our binoculars because there are a few interesting things to see. So we all look at the moon and we all want to see craters. And all these circles here are craters. Everyone thinks about these big dark areas you see with your eyes so clearly as big craters. They're actually called the maria. Each one is a mare or a mare. People pronounce it both ways. I've heard people argue about how you're supposed to pronounce it, so I use both pronunciations just because I'm kind of like that sometimes. And these are giant lava flows on the moon. Now, some of them are impact basins from huge asteroids that plowed into the moon billions of years ago, blasting a hole so deep that the magma beneath the surface filled up and filled the basin with lava. So these are giant lava flows on the moon. And when lava hardens, it tends to harden as a dark colored rock. Now, this one right here is called the Sea of Tranquility. And 55 years ago this month, Neil Armstrong and Buzz Aldrin became the first two human beings to land on the moon. And this is the area they landed. So if you look towards the bottom, and you'll need binoculars, you'll see this one bright little crater right there. That crater's name is Moltke. It's named after Marshall. And the reason he got a crater, even though it's not a very big one, was because he was key in getting a lunar atlas published in the 19th century, the 1800s. And so this crater is named after him. And they landed just above, just north of that crater, right about in there. So see that little white spot just above it? That's where Neil and Buzz landed on the moon on July 20th, 1969. So that's one thing you can look at. Find the Sea of Tranquility and find that little dot right there and know that they landed just above that. Now come over to the Sea of Fertility, this one over here, and you see those two craters. They're not very big either. Each one's about 6 to 8 miles in diameter. And the one on the right is called Messier, and the one on the left is called Messier A. Well, they're named after Charles Messier. We're going to talk a little bit more about later this evening as we get into the stars. Charles Messier was a comet hunter, and he's famous for a list of deep sky objects, and we're going to see some before we're through tonight. But he really wasn't interested in deep sky objects. He was cataloging them so he wouldn't confuse them with comets. He discovered 14 comets in his life. What I like about the Messier craters here in the Sea of Fertility is if you look at Messier A, which is the one on the west side or the left side, you'll see these lines coming out of it. It makes it look like a comet. I'm not sure if that's why they named this pair after Messier. So to me, that's Messier, and there's Messier's one of his comets right there. Those lines are actually ejecta that came out of that crater. When the rock hit that made that rock, stuff went flying, and it obviously came in at an angle, and the stuff all flew off towards the west. But it does have a cometary look about it. I kind of like that. One more feature to consider looking at. We've seen where the astronauts landed. We see the Messier craters with their tail looking like a little comet on the moon. And then we notice right here below the Sea of Tranquility, this nice big crater that stands out right now. That crater is called Theophilus. And Theophilus is about 60 miles, 62, 63 miles in diameter. So that'd be a crater like if one side were in Rangeley, where most of you folks are, the other side might be where I am in Waterville. So that's a pretty big hole in the ground. And the crater rim that goes all the way around it on average is about 4,000 feet tall. So that's the height of Saddleback Mountain. So imagine the ridge of Saddleback Mountain, but imagine if that ridge continued on and made a circular mountain that covered an area that from one side to the other was miles across. That's what you have here. A giant circular Saddleback Mountain going all the way around a plain inside. And that white dot in the center is a central peak that's 4,500 feet tall. So that's taller than Saddleback. So when you look at the moon and you see that, just think about Saddleback Mountain, something that you're pretty familiar with if you live in the Rangeley area. And consider that little white dot right there is larger than Saddleback, and how big that crater is. Not nearly the largest crater on the moon, but one that stands out, especially at this phase of the moon. So those are just a couple interesting things to think about. So let's come back here, and we're going to let it get a little bit darker. We're going to wait, and we'll come back, and if I don't forget, to see if we can see that moon occult spica when we get a little bit later in the evening. So let's go back, look back where the sun was setting. We saw Venus, but you're probably going to have a hard time seeing that with your binoculars at home. Maybe you might see with the telescope, but you got to find it. As that sets, another star is going to appear just to the left, a little bit towards the moon, but not too far away. That's the planet Mercury right there. And that one you're going to have a better time finding. Generally, Venus is a lot brighter than Mercury, but Mercury's farther from the sun right now in its angular wise in the sky. And it's a little bit later in the evening, so you can see a bunch of stars are coming out. So it's getting darker, so it will show up. I know my friend Larry has recently taken some pictures of Mercury, so I know it's definitely visible. Where he hasn't sent me any of Venus yet. Venus is still challenging. Let's let it get a little bit later. Let's let those planets go down. Let a few more stars come out. And high in the northwest right now, we're going to start with something familiar, because I always think it's good to start with something people are already familiar with. And we're going to begin with the old standby of the Big Dipper. So look high in the northwest, and you're going to see the 3 stars of the Big Dipper's handle and 4 stars here for the pot or the bowl. Now, the Big Dipper technically is part of Ursa Major, which is the Great Bear. So let's put some lines on that bear. Doesn't that look like a bear to you? The handle here becomes the bear's tail. The nose is out front, and then we got some legs coming down. Kind of a rough dot-to-dot picture of a bear. You can draw in a fancy drawing like this if you want to. Um, I have a hard time looking at that without the lines and trying to envision anything of a bear there. But the lines, I can kind of make a crude bear out of it if I want to, if I use my imagination a little bit. But most people may not see the bear, but they can find the Big Dipper. Once you find the Big Dipper, the next thing I want you to find is the Little Dipper. To find that, forget about all these obscure parts of the bear. Just think about the dipper, the handle, and the pot. The back two stars of the pot are called the pointer stars. Their names are Merrick and Doobie. You draw a line from Merrick to Doobie and you keep right on going to the first bright star you come to. And that's probably the most famous star in the entire night sky. That's the North Star or Polaris. It's not the brightest star. They're about 47, 48 stars brighter, way down the list of bright stars. It's not famous for being bright. It's famous because it's the only star directly above the Earth's North Pole. So if you draw a line from Polaris to the nearest spot on the horizon, you'll be within a half a degree of true north. That's more accurate than your compass. It also marks the end of the handle of the much fainter Little Dipper. The North Star stands out fairly brightly, but the other stars are quite faint, and you got to be in a dark spot to see it. Now, living here in Waterville, I'm actually in Fairfield, but pretty close to Waterville. If you go into Waterville downtown, you're not going to see these stars. You can see Polaris from down there, and you can see the Big Dipper, but these get washed out. If you're in a dark spot like in Rangeley, you get out of the village, away from the streetlights, there all these stars, if you get a clear night, are going to show up really easily. You're going to see the Little Dipper, no problem. But I want you to take a note here of Polaris, ignore that, I just hit in the wrong spot there. Polaris, the North Star. And I want you to notice the brightness of that, because that's going to be important here in a minute. So now, remember Spica, that's going to be occulted by the moon. Here's an easy way to find Spica. Take the handle of the Big Dipper and follow the arc of the handle down. It points you to the bright star Arcturus. So we arc to Arcturus, and then you speed on to Spica, which it looks like it may already be behind the moon. Maybe we went far enough into the evening. It is behind the moon. If we back up time just a little bit, don't do this outdoors, boys and girls. You'll get in trouble, but we can do it here. I'm going to just make it so the moon doesn't move. Back up, you'll see Spike is going to peek out from behind. It's right there. So that's going to happen probably sometime around 10:30, something like that. So you find it by arcing to Arcturus and you speed to Spica. And if you go outside any night other than Saturday around 10 o'clock, that'll always work to find the handle of the Big Dipper, arcing to Arcturus and speeding to Spica. So that occultation is going to happen on Saturday evening. And it's just a cool thing to witness. So come back to the Big Dipper one more time. Now, if you have a telescope, right under the tip of the Little Dipper, the Big Dipper's handle, there's a star called Alkaid. Go right underneath it, and you're going to see these two stars and this little faint one, a couple little faint ones right here. And I think it's actually this one we want to go to. Let's see if we're in the right spot here. Um, right. Nope, is this one we want to go to? Well, it's pretty close. You're going to find something called the Whirlpool Galaxy, otherwise known as M51. Now, M51, there's 110 M objects, and M stands for Messier. Remember Charles Messier, the guy who was interested in comets? Well, this is one of his objects. This is object number 51. And of the 110 objects he cataloged, these are probably over 100 of the best objects you can find with small backyard telescopes. This one is a galaxy similar to our own Milky Way. We're looking right straight down from the top, and you can see it's a spiral galaxy with spiral arms. This is a smaller galaxy that it collided with, and the collision happened about 70 million years ago, and they're moving apart right now. And when galaxies collide, there's almost no explosions because things aren't actually hitting each other because the space between stars is so great. They kind of go through each other, but it stirs things up. The gravity interacts, and all these little pink spots you see on the galaxy, those are clouds of hydrogen that have got stirred up, and those are places where new stars will form. We're going to see some of those in our own galaxy up close here in a few minutes. Now, this galaxy is the first one where the spiral structure was revealed, and that was revealed in 1845. They didn't know it was a galaxy at that point. They didn't know what a galaxy was. At that time, everyone thought everything was part of the Milky Way. And for the better part of 70 or 80 years, many astronomers believe this was information. We now know it's another entire galaxy. It's 27 million light years away. And it's a beautiful sight with those spiral arms. Now, that's right underneath the end of the handle of the Big Dipper. If you go further underneath, we're going to see another galaxy I want to show you. But first, you notice there's a little cluster of stars right in here. This cluster of stars is called the Coma cluster. And these are young stars. Now, remember those pink patches I just talked about in that galaxy where places where hydrogen is coalescing and will form into stars? Well, each one of those clouds will eventually turn into a group of 300 or 400 stars, perhaps. This was, at one point, there was one of those nebulas here, but the nebulosity is all condensed into this group of stars called the Coma cluster. The Coma cluster is the second closest cluster of stars of this sort to us and the sun and the Earth. These are called open clusters. And the interesting thing about the Coma cluster of stars is right behind it is the Coma cluster of galaxies. Galaxies turned out to cluster too. And this Coma cluster of galaxies, there are thousands of galaxies. I want to show you a spiral edge on, which is right up here. We'll zoom in. This one's called the Silver Needle Galaxy. And you kind of see it looks like a sort of like a little needle. And this is a spiral galaxy, just like the whirlpool, but now rather than looking down from the top, we're looking edge on. So you can see these things are actually pretty flat. I always compare them to be shaped like a frisbee. They're round, they have a spiral structure, but if you get edge on, like a frisbee, edge on looks fairly flat or like a plate. So I just want to give this an example of how galaxies look at different angles. This is edge on, the other one was face on. And this one's called the Needle Galaxy, NGC 4244. NGC stands for the New General Catalog, which is a catalog of thousands of deep sky objects, some of them very obscure. But this is kind of one of my favorites because it's such a good example of an edge-on galaxy. So those are two in that same area. One is easy to find, and the whirlpool is much easier to find than the Needle Galaxy. But it's fun to scan through the Coma cluster and to see either of those galaxies with a telescope. The Coma cluster is fun to just explore with your binoculars, though. So now, remember how we followed the handle of the Big Dipper? We arced to Arcturus, then we sped on to Spica, which is now behind the moon. Come back to Arcturus, and Arcturus is in a constellation that I love that most people have never heard of. It's called Boötes. And Boötes was supposed to be a man chasing the bear. He's the bear chaser. He was also the herdsman chasing the bear away from his herd of sheep. So if you can make this group of stars look like a man, well, I guess if you can make that look like a bear, maybe you can do both. I can kind of make that like a bear. I don't make this look like a man at all. Some people call it the kite, and it does kind of look like a kite with a tail and then a string going off to some little kid flying it somewhere. I often draw it as an ice cream cone with Arcturus as the point. Draw a line, get rid of that, between those two stars. And this little triangle is the cone. And then I'll come out to a couple more of these stars here and round that out a little more, make a nice big scoop of ice cream. So that's Boötes. Arcturus is very bright. It's the brightest star in the northern hemisphere, fourth brightest star in the sky overall. So it's a very significant star. You can't miss it. And the handle of the Big Dipper always points at it. Now, once you find this ice cream cone, a lot of kids have noticed, and some adults too, that there's a nice little half circle right behind it. That's called Corona Borealis, which means the northern crown. The brightest star is named Gemma, which seems an appropriate name for a star in a crown. So I think of it as like a tiara, like a princess might wear, and Gemma is the brightest jewel in the crown. But there is something that's a new jewel is going to appear supposedly sometime within the next several months, and it's going to be just off this star right here. Now, it already exists. It's a star that you will not see with your eyes at this point. It's at 10th magnitude, which means you need a telescope to see it. If you have a telescope, here's what you do. You zoom in on this star, not the end star. Go from Gemma up this curve, go all the way to the end, then come back one star. And right beside it, you're going to see a little curve of stars like the handle of the Big Dipper. Then you're going to see a little square. So it kind of looks like a little tiny little dipper. Just below the pot, this is the star right here. And it's commonly called the Blaze Star. Its real name is T Corona Borealis. And it's at 10th magnitude, and you won't probably even see it with binoculars. You need a telescope. It doesn't look like anything special. And you look at it and you go, why would they call that the Blaze Star? It's not even very bright. It's something that blazes we think of as being very bright. Well, let's take a quick look and see what happens with the Blaze Star and what's going on there. Uh, Here is what's happening. It's a binary star, two stars, one big one, a big orange star, which isn't very dense, but it's very large and very cool. So it means it's not really very bright either. And it has a very tiny star, not much larger than the Earth, called a white dwarf, which is very dense, has lots of gravity. And the white dwarf is constantly pulling material off its partner. They orbit each other, and the little one has more gravity than the big one, and it pulls material off the big one, and stuff falls into it all the time. And every 80 years or so, enough material falls on that white dwarf, and the pressure builds up and becomes great enough that all the hydrogen that's been falling for 80 years ignites in nuclear fusion, and it's a huge explosion called a nova. Not a supernova, but a nova. And it burns all this stuff off, and then it fades away. And it will be, when it explodes, it's going to be bright, week to 10 days, maybe 2 weeks at the most, then it'll fade away and it'll keep gathering its stuff. And then about 80 years later, it'll do it again. The last time it did it was in 1946, about 80 years ago. And what they have found is that just before it does that, um, its dimness fades a little bit. It gets a little bit dimmer for a short period of time, and then suddenly it bursts out. So the question is, how bright will it get? It will get to be the same brightness as Polaris, the North Star. So if we go back to Polaris, that's the star right here. It'll be as bright as that star. Now, you may have heard about this in social media or on YouTube or something, and they talk about this star exploding and the whole sky is going to be lit up. And well, it is a star that is exploding, and it does it every 80 years. But it's not going to light up the whole sky. You're not going to go out and go, oh my goodness, what is that? It's just going to look like a new bright star, about the same brightness as this. Not as bright as Arcturus, maybe a little bit brighter than Gemma. So the crown will have a new jewel, but the jewel's only going to last for a week or two, and then it'll fade away. So what I would suggest is get so you can recognize that northern crown. It doesn't take long. Arc to Arcturus. Find the ice cream cone and the half circle behind it. That's the crown. Notice Gemma. And if you notice Gemma, and then there's a bright star equal to it to the left or to the west, you'll have seen the Blaze Star. And it won't do this again for 80 years. So us who are more than 15 years old probably are not going to see this again. This is a one-time deal. So it's something I'm watching for. I'm hoping to get a chance to see it soon. Now let's move from there down low in the southern sky to one of my favorite summertime constellations. I'm going to bring it up here so we're looking down low. And we'll see Scorpius the Scorpion. And the Scorpion stands out because of this bright red star, very much like the red star in the Blaze Star, only this doesn't have a white dwarf around it, so it's not going to go nova anytime soon. This one may go supernova. This is not just a red star like the Blaze Star. This is a red supergiant star. It's huge. If the sun, which is, by the way, is 1,000,000 times larger than the Earth, if we made this a scale model of the sun where the sun is the size of a basketball, Antares, that's the name of this red star marking the heart of the Scorpion, would be a ball 1/4 mile in diameter if the sun were the size of a basketball and the Earth were the size of a grain of sand. It is a huge star, and it will explode one day. And it's probably within the next 1,000,000 years, which astronomically is like anytime soon. Well, if you find Antares, it marks the heart of the Scorpion. This is his heart. This is his head, a claw on each side. A long body comes down, then the curly tail comes up to the bright star Shula, marking the tail right here. The shawl right there. And with the combination of the star behind it, makes a nice little stinger at the end of the tail. So that's Scorpius the scorpion. And I can kind of make that look like a scorpion. Traditionally it would have been drawn something like this. But I think the dot to dot works better because as much as I love the artwork, when I go outside at night, I have a hard time seeing those beautiful pictures floating in the sky, whereas I can always connect the dots to make the scorpion. Now, right behind the scorpion's tail is one of my other favorite summertime constellations called Sagittarius. It's these stars right in here. Now, you know your mythology, you know that Sagittarius was a centaur. Centaur is half man, half horse. And as if that weren't complicated enough, he's shooting a bow and arrow. So look at those stars and see if you can see half man, half horse shooting a bow and arrow. If you can see that, you're doing way better than me. And I've been doing this for over 40 years. Um, Most people don't even try to make Sagittarius into a centaur, just like most people just make the Big Dipper versus the Great Bear. Well, this one's even harder to make it look like a centaur than the Big Dipper is a bear. So most people instead turn it into a teapot. So here's the base of the teapot, spout on one side, a handle on the other, and a lid on top. Makes a nice little I'm a little teapot. And right between the two, remember the coma cluster of young stars? There's another cluster right here. This one's called Ptolemy's cluster. And Ptolemy's cluster, you can see without a telescope. You can see it with binoculars, but you can see it with just your eyes. That's because Ptolemy saw it and wrote about it in 130 AD, almost 1,000 years ago, and there were no telescopes back then. So it's been known of for a long time. There are about 80 to 100 stars in this group. They're about 850 light years away and maybe in the neighborhood of 200 million years old. That sounds old, but for a star, that's kind of like being a teenager. And I always say teenagers like to hang out with their friends, and so do teenage stars. In a pair of binoculars, you see this beautiful cluster of young stars. We know they're young by studying the spectrum. You take the light from the stars, put it through a prism, and you get the rainbow, which we call a spectrum. And by studying that, we actually find little lines and things in it that tell us what stars are made of. And young stars are made primarily of hydrogen, maybe a little bit of helium. That's what these things are made of. When you look at old stars like Antares, that red supergiant we just looked at in the Scorpion, that has all kinds of lines of lots of things besides hydrogen and helium. That tells us it's an old dying star. So these are young stars. There's another little cluster up here, another open cluster further away. That's why it looks smaller. This one's called the butterfly cluster. By the way, they both have M numbers too. This one, Ptolemy's cluster is M7 and the butterfly is M6. So he noticed these. Of course, his telescopes did not give you nearly as good a view as your binoculars do today. So you have much better optics than they had 250 years ago, even if all you have are binoculars. So let's back up a little bit, and I'm going to get rid of the lines here for a second. And remember that Needle galaxy and the Whirlpool galaxy? We live in a galaxy too. Our galaxy is called the Milky Way. And this is the best time of year to see it. Now, I have these stars set more for the way they look for me here in central Maine than the way they look for you up there in Rangeley. You have very dark skies in Rangeley because you don't have the light pollution we have here in the Waterville area. So this is the way it might look, not from downtown Waterville or downtown Augusta, but from out in the countryside in this area. In Rangeley, let me show you the difference. This is central Maine. Here's places like Rangeley or the AMC properties up near Greenville or Katahdin Woods and Waters or places in Washington County. The sky would look more like this. That's quite a bit more dramatic, wouldn't you think? See a lot more stars. It does make learning constellations a little more challenging with more stars in the background, but it certainly is a much more beautiful view. And you can see the Milky Way a lot better too from a dark location. This band right through here is the Milky Way. And the center of our galaxy is right in this region, right here, right in front of Sagittarius. You see the teapot right in there, and the Scorpion right in here. So you can put the lines on the Scorpion right there. And Sagittarius, they try to draw it here as the centaur, and I don't know how that's supposed to look like a centaur, but you can see the teapot in there. And the center is right between the two, right in the area of Ptolemy's cluster and the butterfly cluster. Now, when we looked at that Needle galaxy, we're looking edge on. Now, you have to understand the difference here is we're inside the Milky Way. All these stars are the stars around us. We're within that band. And the stars who are around us are the ones that are on just around in our neighborhood way. If we take them out of the field of view and get rid of the ground like we're floating in space, you can see that our Milky Way will start kind of like that needle galaxy. So let's get rid of the ground first. And then let's just get rid of the stars for a moment, our neighborhood stars. And you can see that our galaxy kind of starts to look like that needle galaxy. We're looking edge on into the thickness from where we are because we're not out near the edge. We're not in the center. We're about halfway out from the center to the edge. And so here we're looking in towards the center of our galaxy, going both ways. Now, the stars we see are part of the galaxy too. We've just kind of taken them out of the view so we can see the kind of the central part of our galaxy. But it gives you a sense of how we know what our galaxy looks like by studying all those others. And I just think it's a pretty spectacular view. We never get to see the whole thing because the Earth is always partly in the way. Well, once you found the Scorpion and you found the Milky Way, go high overhead, almost straight up, and you're going to see three bright stars. The brightest one, just to the west of the Milky Way. And then you have Altair and Deneb. That's called the summer triangle because it becomes visible in the summer, though it lasts through the whole autumn. And it's not a constellation. It's what we call an asterism, just something easy to recognize. So we have the asterism of the summer triangle. And I'm only going to concern ourselves today with just one of those constellations. It's the one with Deneb, which is Cygnus the Swan. So let's see if we can make a swan here. There's our swan. Deneb is an Arabic word which means tail, so that's the swan's tail. This star's name is Satyr, and that's the shoulder. Got a wing out here, and I usually draw a line back to Deneb, fill that wing in a little bit. And the other wing comes out here, and then I draw a line back to Deneb again and fill that wing in. Come up to the shoulder, and we come all the way down to Albireo, which is the star that marks the swan's head. So there's our swan flying across the sky. To me, I can kind of see that. Put the artwork up there, and it's pretty easy to envision this swan. This constellation does have an alias, as many do, just like the Big Dipper and the Great Bear or the Teapot and Sagittarius. This one's also known as the Northern Cross. See the Northern Cross? This is the upright piece of the cross, and we just use these three stars for the cross piece. It makes a Christian cross, kind of lined up with the Milky Way right here. Now, there's all kinds of interesting stories about this. And one of my favorite ones is a native story, and I'm going to just simplify it here down. It had to do with a pond, and this pond was considered somewhat magical because it reflected the sky so perfectly that you could see every star in the sky by looking down into this pond. And even when the wind blew, the way it was nestled in the trees, the wind seldom ruffled the water, so it was almost like a perfect mirror. And the father and his son went there, and he told his son about this sacred pond where the stars could be seen in the pond. And you were never supposed to disturb it because maybe they wouldn't appear again. And when they got there, he was teaching his son to hunt, and they looked out, and there was a swan swimming in the pond. And his son got ready to shoot it with his arrow. And the father said, "No, no, don't shoot it. It's in the pond. It's safe when it's there." And the boy held back. And then suddenly the swan took off. And when he took off, the boy picked up his bow, and before his father could stop him, he shot the arrow. And if you look right below the swan, this little group is called Sagita the arrow, flying through the air. Well, the story goes that the boy hit the swan and killed it. And the swan fell with its wings stretched out, fell flat into the pond, and the ripples ran across the water and faded away. And when it all faded away, they looked and there was a new group of stars in the pond in the shape of a swan. And then they looked up in the sky where there'd never been a swan before. And then suddenly there was a swan in the sky. And so when the swan fell into the lake made the swan into the stars in the reflection. And part of the idea of the story was that it wasn't really that the pond was reflecting the stars, this pond was creating the stars. And I always kind of like that story. And so that's one of the stories of the swan in the sky. And you even have the arrow flying by here. Now, we talked about a star, the blaze star, which flares up every 80 years. And it kind of explodes, but it doesn't destroy itself because it just keeps burning. It just burns as fuel. It's like turning on the gas too high and you get a big flame and you turn it down, it goes away. Well, there are stars that do die, and all stars die eventually. And eventually, in about 4 to 5 billion years, the sun will die. Well, if you go to Sagitta, the arrow right here, you see the little arrow, go to the brightest star. Let's zoom in on it here. You're going to notice just above it, there's a nice little triangle. See that triangle right there? Go to the left-hand star, that one right there. Zoom in. And what you're going to find just underneath that star is the remains of a star that died that was similar to our sun. That's what this little thing is right here. It's called the Dumbbell Nebula. And the Dumbbell Nebula is M27, Messier 27. Old Charles Messier, he saw lots of things in the sky, and this is one of them. The Dumbbell Nebula is away. And and it died about 48,000 years ago, which in stellar terms is not that long ago. So this one, these stars die like our sun, the sun's not going to explode. It just pushes the outer layers away. So the sun doesn't have enough mass to make it explode in a giant explosion. What happens is the fusion that's happening in the core of the sun, which makes it shine, it starts moving outward, and it finally gets to the point where it's not in the core anymore, but it's in a kind of a shell surrounding the core. And when the fusion starts in that shell, it just pushes the outer layers away and they go drifting off into space. And these are the outer layers here, and they're drifting off in different directions in space and is slowly getting larger and dispersing into space. So it's called the dumbbell because someone thought it looked like a dumbbell. I often think of it as the apple core nebula because to me it looks more like an apple core. When you look at this with your telescope, you'll see the structure, but you're not going to see the color. The color only comes through if you take photographs. Remember how we talked about the northern lights don't look as bright to our eyes as they do when you take a picture of them. Well, most deep sky objects, when you look at them with your eyes, they're in grayscale. They're in black and white. You won't see much color, but if you take a picture, take a photograph through the telescope, or however you do that, the color comes through. The color really is there. It's a weakness in our eyes, not because the color's not there. So that's the way stars like our sun die. Now, there are stars that explode, and only giant stars explode. Our sun will never explode. It's not big enough. For a star to explode, it's got to be 8 to 10 times more massive than the sun. And one of those did explode right off the wing of the swan. So come back over here to our swan and come down to the lower end here to the eastern side. And right about in here is an area where a star exploded. And this star exploded 15,000 years ago. So it's younger than the Dumbbell Nebula. And it's pretty hard to see through a telescope, but it's very easy to photograph. I photographed it several times. See here is called the Veil Nebula. And you can kind of see it does have a veil-like appearance. This object is 2,500 light years away. And this was a giant star that basically what stars do is in their core, they turn hydrogen into helium. That's what the sun's doing right now. When the core is all helium, then the helium starts turning into carbon and neon. And then when that gets to be mostly carbon and neon, it starts turning into oxygen and nitrogen and different gases and things. Eventually, these stars start turning things into iron. And no matter how big the star is, no matter how much pressure there is, iron doesn't like to fuse. And all these reactions gave off energy. But when they start fusing into iron, it stops giving off energy. And this giant star, a star like Antares and the Scorpion, will suddenly collapse on itself because there's no outward pressure of the fusion in the core anymore. And this giant star that might be equal to, 15, 20, 30 suns, maybe 100 suns or even more, will collapse on itself, implode. And when it does that, it'll create one giant fusion reaction that will create everything heavier than iron. And it'll blow itself to smithereens. And that's what happened here 15,000 years ago. When this exploded, it was brighter than the full moon, though it was just a pinpoint of light, just like any other star in the sky. But imagine a point of light no larger than a star, so bright it was as bright as the full moon. It would have hurt your eyes to look at it because it was so concentrated. And when that exploded, it created everything heavier than iron. That's how everything heavier than iron was created. So if you have a wedding band on made of gold, or you have earrings made of silver, You should realize that all the silver and all the gold on the planet Earth was created in an explosion like this. So if you have any jewelry made of silver or gold, you have a piece of a supernova wrapped around your finger or dangling from your ears right this minute. Isn't that cool to think about? Well, this is called a supernova, whereas the blaze star is a nova, which can happen over and over again. This happens once. So this is a supernova, a star dying and exploding and blowing itself to smithereens. Pretty dramatic thing to see. And that may happen to Betelgeuse in the winter sky or Antares in the summer sky. It could happen tomorrow, or it might happen a million years from now. On a stellar scale, there's not much difference. On a human scale, it's huge, but you know, that's just the difference between us and stars. Stars live on a different scale than we do. Well, to finish up here, because we are getting low on our time, I want us to look over into the east. We're around midnight now. And around midnight, a bright star is going to come up. Oh, I'm sorry, I went too far. I was busy talking and not looking at what I was doing. You're going to see a fairly bright yellowish star right here in the southeastern sky. And that it turns out to be another planet. And this one, oh, I'm sorry, this one right down here, I hit the wrong one, is the planet Saturn. Did I hit the right one? No, I didn't. Hold on. I got to go a little bit later in the evening. You're going to have to forgive me here. Let's just go just a little bit later. There it comes. There's Saturn right here. Let's turn off all those constellations. I thought I had it up and I didn't. It's right here. That little mound we have on the ground was covering it up. This is the planet Saturn, rising after midnight, basically. And each night it rises a few minutes earlier. So by August, it'll be out as soon as it gets dark. So Saturn is everyone's favorite planet because if you have a telescope, you can see the rings, at least right now. Now you might think, well, I thought you could always see the rings. And you're going to find them harder and harder to see through this winter because the rings are getting to the point where they're almost edge on. Now, for the last couple of few years, the rings have shown up nice and clear, but look how edge on they are right now. And they're going to get more so. Every 15 years or so, we pass through the plane of the rings. And when you look in at them edge on, you really can't see them. That's because Saturn is 1 billion miles from here. That's a very long way. And those rings, while they may be very wide from the inside edge to the outside edge this way, maybe 30,000 miles. If you measure them top to bottom, thickness wise, average thickness is 80 yards. Yards. That's less than the length of a football field. So if you could tip Saturn up on edge and bring the rings down edgewise to the 50-yard line at the Super Bowl, the rings would fit between the goalposts and they'd extend 30,000 miles into the sky. Wouldn't that be a halftime show? But anyway, something that's only 80 to 100 yards thick, 1 billion miles away, is not going to be visible. And next March, when we are edge on with them, they're essentially going to disappear. And for several months, you won't be able to see the rings of Saturn. And then when they do start to reappear about a year from now, we'll be looking up from the bottom versus down from the top. So our angle of view is going to change on them. So you can see the rings look like they're getting thinner and thinner. It's just because our angle of looking at them is changing. Saturn itself inside the rings is about 700 times bigger than the Earth. It is low density. There's no ground. You can't land here. And the density is lower than water. So if you had a giant bathtub big enough to drop all the planets in, they'd all sink to the bottom except for Saturn. It'd bob around and float on top. The only planet that could float in water. Be some bathtub, though. So there's Saturn. It's over in the eastern sky, a little after midnight tonight, or any night soon. But as the summer goes on, now, if you're a place like I am here where there's a little more light pollution, you see it stands out a little bit better, doesn't it? Versus in a place where there are lots of stars. Even though it's easier without all the stars, if you can see all the stars, don't complain because most people in the world can't see that. If you want to see more planets, then what you need to do is you need to stay up even later. So I'm going to keep you up late. It's already midnight. And if we stay up and look, coming up right here in the eastern sky, and this is going to be, let's stop it right there. This is going to be around 3 o'clock in the morning. You see this reddish star right here? Well, that's the planet Mars. And Mars is right beside another open cluster like Ptolemy's cluster or the Coma cluster. This one's called the Pleiades or the Seven Sisters, something we associate with the wintertime because the stars you're seeing just before sunrise, like 3 to 4 in the morning before the sun comes up, are the same stars we'll see in the evening come January. So we can see wintertime stars in the summer if you get up before the sun comes up. And right now you can see Mars. And if we stay up a little bit later, we'll find another bright star. You see the glow of the sun starting to appear here. This really bright one here is Jupiter. Now, Mars isn't much to look at with a small backyard telescope, but Jupiter's always worth a look, just like Saturn is. And when you look at Jupiter, this is Saturn, remember, you'll see Jupiter. You might see these two bands if you have a telescope. They'll look like gray bands. You won't see the color, remember, that only shows up in photographs, but you'll see those two gray bands. Those are cloud bands. Jupiter has no ground, so you can't land on it, and the wind blows through those clouds at like 100 miles an hour. One band, it goes west, the next band, it goes east. And go for a wild ride if you fly into the clouds of Jupiter. Jupiter is famous for all of its moons, at least 96 moons going around it, but only four big ones. With the backyard telescope, you're only going to see four. You can see one, two, three, four. Now, they look really huge here, almost as big as Jupiter. That's a function of this program. They just make them so you can clearly see them. If you look with a telescope or a pair of binoculars, and you can just see the moons with binoculars, they're going to look like little stars in a line. And on Saturday night, you see they're all on the right-hand side of Jupiter. Now, if you wanted to see how they change from night to night, let me just lock that in there. And let's come back to tonight and see what they look like if you went outside tonight. We'll change the date from the 14th, because remember, we moved in past midnight, so this is Sunday morning. This is, oops, it didn't stay there. That was going to stay. There it is. This is Saturday morning. So let's stop time for a second right there. By Saturday morning, you can see the moons. Now we've got two on the left and two on the right. And then if we go back, let's see if it's going to stay there again. We'll back off just a little bit. Oops. Now I lost it. Oh, it's way up here. I'm not sure why it was doing that. Go back to the 11th, which is tonight. And you can see, again, we have two on the left and two on the right. So they move back and forth from night to night. If you go to the 13th or Sunday morning, they're all going to be on the right side. And if you go sometime next week, they might all be on the left side. And sometimes you have 3 and 1 or 1 and 3 and 2 and 2. They're constantly moving. So it's kind of fun to go from night to night and see how those moons change their position as they orbit Jupiter. So those are some of the interesting things you can see if you get outside some night soon. And by the way, there is the last thing I'll leave you with here. Let's come back around to the northern skies. I guess I went the long way around, didn't I? And we're going to back up to get the Big Dipper up a little bit higher in the sky because we have a comet you can see. And the best time to see it is right after the sun goes down. You're going to need a telescope or binoculars, but it's right by the feet of Ursa Major, the Great Bear. So remember, the Great Bear is right here. You see his 2 feet here and the 2 feet here. And if you look just beyond, there's 2 more stars here. So it's 3 pairs, 1, 2, 3. They're also known as the 3 leaps of the gazelle. And right now, right about here between these 2 feet, there's a comet, and you won't see it with your eyes. With binoculars, from what I've read on Sky and Telescope, you can just barely see it. And you see it better with the telescope. It'll look like a fuzzy little star. You probably won't see much of a tail, maybe just a hint of a smudge to one side. It's called Obler's Comet. It's a periodic comet, which means it comes by this one every 69 years. And it's called 13P Comet Obler. And so it's one that you can see right now, and it's moving this way towards the south. So it's right between these feet here, and it's going to move towards these 2 over here, right across the horizon. So you want to get outside as soon as after the sun goes down, and you've got to wait till it's pretty dark though, but not too late. You don't want those feet to go below the horizon because it's just below those feet. So to give you another idea of how to find it, let's go back here one more time. And I've got a picture that will help you. Here's where you'll find it right here. See the 3 leaps of the gazelle, the 2 feet of the Big Dipper, or Ursa Major, and the other pair here. And tonight is the 11th, so it's going to be right about there. And on the 13th, Saturday night, it'll be about here, and it's moving towards those stars. And it will slowly fade away because it's already been at perihelion, which is its closest point with the sun, and it's moving away from the sun now. So that means it's slowly getting fainter and fainter. But I've read that you should be able to see it. If you're in a dark spot like you are in Rangeley, you should be able to see it with a pair of 7x50 binoculars, and even better with a telescope. So I challenge you to get out and find Comet Obler, Obler. Anyway,